Looking at the warm-up, it says find the area of the unshaded sector. Purposely put this one because I know we talked about finding the unshaded given the shaded. All right, so if I'm looking for the area of the unshaded sector, first off, what formula am I using for the sectors? I'm using the 4 formula. The question is, which formula am I using? The proportion one, the one with the area, okay? So if I'm looking for the area of the sector, does my x go on top or on bottom? In the numerator or denominator? The top, top left or top right? All right, area of the sector is always over the area of the, what do I have? All right, remember this is your part out of 4, but what am I going to use with the 4? The area of the circle. So this should be pi 4 squared. Okay. On the right side, we should have the central angle. What's our central angle? How did you get 290? All right, and the difference would be 290. All right, so 290 for the unshaded region. So the unshaded region down here would be 290 degrees. And then out of the total, which is 360. All right, cross multiply that for me. Remember, when you multiply that first piece, do 290 pi 4 squared. And then whatever you get after that, then divide it by 360. What do we get to the 10th place on that one? 40.5? All right, so 40.5. And then whatever the unit is squared. As we get into the area of regular polygons, remember your polygons, these are going to be everything but your quadrilaterals. So it'll be your pentagons, your hexagons, your octagons. All of these are going to have the same formula. All right, so let's talk about different parts. So the center of the polygon, what would I name the center of the polygon? What's my point at the center of the polygon? Point P. All right, so this would be point P. Thanks. All right, this is your center. The radius of the polygon, now make sure your radius is touching your circle. So if I was to go from the center here on this blue line, does that blue line touch my circle? No, that's not your radius. Your radius has to go from the center to your circle. And I'm going to tell you now, on your polygon, it's going to be touching the corners. Anytime you draw your radius, it'll be that vertex, the vertex on the polygon. So P to N is a radius. What else is a radius? P to M. All right, so P to N and P to M. P to N and P to M. The next one's asking for the apothem. The apothem appears to be like a radius, but that's the one that doesn't touch the circle. So that's going to be that blue line. So here, our apothem is going to be P to Q. All right, and the apothem is what we'll be using to find the area. Now, to find the central angle, the angle in the center, all you do is you take 360 and divide it by the number of sides. The reason being is here I have angle MPN. If I continue to make central angles to my vertex, the number of angles, 1, 2, 3, 4, 5, 6, is the same as the number of sides. So as long as you know your number of sides, you can get your central angle. For instance, this one is a hexagon. What would be 360 divided by 6? 60. Then 60 would be your central angle. Now, you're going to have to know your central angle. This section, continuing on, that Pythagorean theorem and that trig is going to be used for any piece that's missing. All right, let's just talk about the parts real quick. It's a square FGHJ is inscribed circle K. Identify the center, the radius, the apothem, and the central angle of the polygon. Then find the measure of a central angle. All right, let's look at this one. Where's the center located at? Point K. The radius is from K to G. Good, always the vertex. So we can say K to G, or what else could we say? K to H. The apothem, again, it's like a radius, but the apothem goes only to the midpoint, to the side. So what would be an apothem? K to L. All right, the central angle has to include the center. All right, this is going to be made with pretty much with your two radii. So it's going to be angle G, K to what? H. Angle G, K to H. What would the measurement be? How would I figure out the measurement? 360 divided by 4. That would give us 90 degrees. This would be a 90-degree central angle. All right. So with that said, the formula for the regular polygons is actually derived from getting the area of a triangle created in here and then multiplying it by however many triangles you have in there, okay? So here we have a stained glass window. It's a regular octagon, regular meaning that all the sides and all the angles are what? Equal. Everything's congruent. It says with the side length of 15. So down here, this is where the 15's at. It says the apothem is 18.1. I think it might be hard to see, but it's right here, 18.1. It says, what is the area of the covered window? So you notice here I have this triangle outlined for us. How would I find the area of the triangle? What formula do we use? Yeah, base times height divided by 2. Our base is 15. Our height is, it's the apothem. Good. All of it divided by 2. Good. All right. Can y'all let me know the area of that one triangle? What was that? 135? Exactly? 135.75? All right. Now, this is the area of one triangle. Don't look at the lines because the lines are going to confuse you. You want to go to vertex. So there's one triangle. This one makes 2, 3, 4. And I'm going to the vertex. 5, 6, 7, then 8, right? Because we said it was an octagon. So to figure out the area of the whole thing, what do we want to do? Yeah, just multiply by the number of triangles. I'm going to multiply it by 8 because we have 8 triangles. So what would the total area be? 1,086. Exactly, okay? And this would be in inches squared. Now, you're always welcome to find the area of these regular polygons this way. There will be some instances, though, where you won't have everything. So regardless, you're still going to have to use Pythagorean theorem or trig to find those missing pieces. All right, if you look over on the right side kind of has an example there. This one's talking about the regular hexagon. The side length is 3 with the apothem of 1.7. Go ahead and find me the area of this whole hexagon. Base times height divided by 2. Leon, what did you get for base times height divided by 2? 2.55. So everyone agree 3 times 1.7 divided by 2 is 3.55? 2.55? Okay, 2.55. All right, and then multiplying that by how many triangles? 6 gives us a total of 53.3? 15.3. All right, and then that would be the total of the hexagon. So if we take the same idea, and this is what we've been doing, right? We took the area of a triangle, we multiplied it by the number of triangles. This is how they came up with the formula. All right, so base times height divided by 2 is the formula. Again, number of triangles. Instead of looking at the base, they called it the side. All they did was call this the side. Okay. For the height, instead of calling it the height, they just called it the apothem, because technically that's the apothem of the polygon. And then the perimeter, or the number of triangles, is just the number of sides. So what they did is they found the perimeter by multiplying the side length by the number of sides. All they did was put the sides and the number of sides together. That is your perimeter times the apothem divided by 2. So everything we just did is pretty much what the formula is asking for. All right, so this is the formula you'll see on the formula chart. You will not see this one, even though that's exactly what it is, because you have to know what perimeter is, right? Perimeter is just the number of sides times its measurement. All right, so this is what your problems are gonna look like. Now again, you can do it by triangle multiplied by the number of triangles, it's fine with me. It says find the area of each regular polygon, round to the nearest tenth, here is a regular hexagon. So, for the formula, if I was using the apothem formula, apothem perimeter divided by 2, do we know the apothem measurement? Do we know the measurement right here? No. So even if you were trying to find just the area of the triangle, this first step is going to be the very first step you're going to do. So the very first step is to find that measurement. So what you're going to do every single time is you're going to find your central angle first. What is the measurement of your central angle? How are we finding it on that first example? We did 360 divided by what? 6. And that gave us 60 degrees. Now, that is the whole measurement right here. This entire angle is 60 degrees. You don't need the whole 60. You need half of it. So then what would be half of 60? All right, so then 60 divided by 2 is 30. Once you find your 30, you're going to go to step 3, and step 3 is just going to have you look at it as a right triangle. So here's your right triangle. Half of that angle is 30. You have 3 at the bottom. Well, I don't want the full 3. I only want part of it. What would be half of that 3? 1.5. And then you're looking for the apothem, or the height. That's what you're looking for. So at this point, it's either trig or Pythagorean theorem. Okay, so this one is trig. So given that I have 30 degrees, or you can even use 30, 60, 90s if y'all remember 30, 60, 90s. So if this is your 30, and that's your opposite side, and you're looking for the adjacent, am I using sine, cosine, or tangent? Tangent. Tangent of 30 is equal to your opposite side times your adjacent. All right, let me know what you get for the apothem here. Times 30. All right, what did y'all get to the 10th place? What'd y'all get? What'd you get for the apothem? 2.9? Ooh, 1.5 divided by tangent 30? All right, and then that was the piece we needed. This was the apothem. All right. So once you have the apothem, now you can find P, or perimeter. What do I want to multiply to get the perimeter? 3 times how many sides? 6 sides. 3 times 6 is 18. This is your perimeter. These are the 2 pieces you need. Once you have these 2 pieces, you can just plug it in. So the apothem is, we said 2.6 times 18, all of it divided by 2. Now there are several steps with these shapes. So I always box in what my final answers are so that when I'm working, I know exactly what numbers I'm using. All right, so 2.6 times 18, and then divided by 2, did we all get 23.4? All right, so the area for this one comes out to be 23.4. Now, you could have done, again, the base times the height divided by 2 times 6. It would be the same process. It would just look slightly different, but you are doing the exact same formula. All right, if you want to go about it that way. All right, let's go over to the back side. So we just have more of these different scenarios I'm showing y'all with these. So with this one here, this one's a pentagon. All right, no matter what, your first step is going to be to find the central angle. All right, and how do we find the central angle? We take 360 and divide it by 5. In this case, it's 360 divided by 5. And that gives us 72. Then you got to take that 72 and divide it by 2. That gives us 36. Every time, if you're using trig, you're going to have to divide that by 2 to get half of that that triangle. So on step 3, you're going to draw me that triangle. It kind of helps you to draw it separately. Here we have 36. Does the 10 go as the height, as the base, or as the hypotenuse on this right triangle? The hypotenuse. I'm going to put the 10 here. What are we missing to find the area? What's the one thing we don't have? We don't have the side, the base. So you're going to find me this side down here. You're going to find me the base. All right. Give you a few seconds. Decide if it's sine, cosine, or tangent. What did y'all pick? Sine. So this should be sine of 36 is equal to the opposite over the hypotenuse. All right, let me know what you get for that side length. What'd you get, Ireland?
5.8.
So about 5.9, right? So about 5.9. All right, is this the full side of the pentagon? No. So what do I have to do with the 5.9? Multiply it by 2. All right, so 5.9 by 2 gives us 11.8. Now 11.8 is just one side. All right, and I'm just writing these notes so that when you're looking at your notes, you know exactly what we're finding. All right, so can I figure out my perimeter now? Good. So down here, I'm going to leave some space. I'll tell you why here in a minute. For my perimeter, I'm going to do one side, which is 11.8 times how many sides? 5. Your perimeter comes out to be, what'd y'all get? 59 exactly. All right. Do we have the apothem, or the height of the triangle? No. So you can do this 2 ways. You can use the 5.9 and do Pythagorean theorem, or calling this y, I can come back and say, okay, now I'm looking for the adjacent in the hypotenuse, and I'm going to use cosine. So I'm going to use cosine of 36 is equal to the adjacent over the hypotenuse. And that would give me 8.1 for the apothem. All right, because we need this side. We needed the apothem. You're going to need that side for all of these regular polygons, okay? All right, so then once we have it, now we can find the area. You got your 2 pieces, you got the A and you got the P. So for the final answer, I would do area equals apothem times perimeter divided by 2. Our apothem we said was 8.1. The perimeter we said was 59. All of it divided by 2. Good. So 8.1 times 59 divided by 2. $20.25. Yes, no? Maybe? $238.95. All right, so area equals 238.95. And this would be inches squared. All right, so let me give you some time to work on 2A. As you're working, I'm going to slowly put up the first step. That way you kind of check your steps as you go. All right, so your central angle should have been 90. Half of that should have been 45. So then on step 3, just make sure that when you made that 45, 45, 90 triangle, that the 7 was right here on the hypotenuse, okay? Just make sure the 7's there. Now on this one, you are looking for both again. So on this one, you're going to look for half the side to get the full side, and you have to look for the apothem. You're going to have to look for both. So, all right, so looking for the x, did y'all use sine, cosine, or tangent looking for the x, given that you have the opposite and the hypotenuse? Sine, cosine, or tangent? Sine. So this should be sine of 45 is equal to x over 7. What did y'all get for 7 sine of 45? Paxton, what'd you get on that one? Finding the opposite side? 4.9. Is 4.9 going to be the whole side? No. What do you have to do with the 4.9? Multiply it by 2. So the whole side will give us what? 9.8 is the side. This is just your side length. All right, and then if we want to, we can continue with the trig just to finish up the trig. If I'm looking for the apothem, which happens to be this side, I would use adjacent and hypotenuse. Is that sine, cosine, or tangent? Cosine. Cosine of 45 is the adjacent over the hypotenuse. So what do we get when we do 7 cosine of 45? 4.9. All right, and this is the apothem. So this one you don't have to do anything else to. You can just go ahead and label the apothem. Now, can I figure out my perimeter now? Yeah, so for the perimeter, we're going to do 4 sides times, what was our side length, 9.8? All right, so what's 9.8 times 4? 39.2. And then as a final step, now you plug it into your formula. So area equals apothem times perimeter divided by 2. 4.9 times 39.2, all of it divided by 2 gives us our area. So times 4.9 divided by 2. Did we all come out with 96.04? Okay. Now, I know this is work. I know it takes steps. Again, going into Algebra 2, you're just going to have problems that are going to be like this. It's going to be work, but doesn't mean it's impossible. Now, this one does distinguish y'all from the advanced, our advanced group from our on-level group. The on-level group, we would give them the apothem, we would give them the side length, right? That's all they would have to do, is just plug it into the formula. But with you guys, y'all can figure it out, right? All right, the last one I want to give you, because you'll have some like this, is you have to draw it yourself. So it says here we have a regular hexagon. I don't care if it's pretty or not, you draw me a 6-sided shape. 1, 2, 3. Just do kind of a trapezoid, and then do a trapezoid right underneath it. 4, 5, 6. It says has a side length of 8 square root of 2. So if you want to put it at the bottom, that's fine with me. It says what is the area? Well, the only thing you have to figure out, what's the only thing you're missing? Can you figure out the perimeter right now? Yeah, so do it. 1, 2, 3, 4, 5, 6. 6 times 8 square root of 2. Right, and then just enter it just like that. 6 parentheses, 8 square root of 2. I got 67.9. Did y'all get 67.9? All right, so you got your perimeter. All you have to worry about now is finding that apothem. So, same steps. First step, you have to find the central angle. 360 divided by 6 is 60. If you want to go ahead and divide it by 2 again there, you can, and we get 30. You have a 30, 60, 90 triangle. And you'll kind of notice the patterns on the shapes, right? Hopefully you'll maybe remember that a hexagon, half of that triangle will always be a 30, 60. All right, and then you can just do 8 square root of 2 divided by 2. So enter 8 square root of 2 in your calculator, whatever it is, divided by 2. You can convert that to a decimal. It's about 5.7. So half of that triangle is 5.7, half of that side, not half of the triangle. All right, all I care for is the apothem. Now, guys, y'all can do 30, 60, 90s here too, right? If this was your short leg, what did y'all do to get the middle leg? You multiplied it by what? Who remembers? Square root of 3. And if you did that, you'd get your answer. If you don't, right, because we may not remember, just do trig. Opposite and adjacent. This is tangent of 30 equals 5.7 divided by 8. Did y'all get 9.9? All right, you would do this, get the same thing if you did the properties of a 30, 60, 90. This is my apothem. You can go ahead and label it. Like, that's what you were looking for. That was the last thing you needed. You just needed that A. So once you have it, now it's a matter of finding the area. Area equals apothem times perimeter divided by 2. We have 9.9. We said the perimeter was 67.9. All of it divided by 2. So 9.9 times 67.9, all of it divided by 2 gives us an area of, since this is a 3 decimal answer, I would just write the whole thing. On the homework, if I say rounded to the tenths, then just round it to the tenths or so forth. Okay. All right, now, this is the hardest problem, I think, because you have to know what shape I'm looking at. So if I say it's a pentagon, do you know how many sides the pentagon has, or the decagon, or the dodecagon, right? That was all that's where chapter 6 is coming in. And then if I gave you, let's say, the radius, just know the radius, and I'm going to emphasize it one last time before we're done, is that is always to the vertex of your polygon. That's going to always be your radius. This is your radius. If it's not that, it's the apothem or the side, okay? All right.